In section 8.4, we're going to take a look at using scientific notation. This relates to the properties of exponents that we've been discussing, and so hopefully you have a pretty good handle on those. Otherwise, you might be a little bit behind the eight ball here. So, what is scientific notation? Scientific notation is a number is written in scientific notation when it is of the form c times 10 to the n, where c is some number between 1 and 10. Okay, so that's the big thing right here, is that you got to remember c has got to be a number between 1 and 10. Okay, so obviously this is what you see on your notes. So a number is written in scientific notation is of the form c times 10 to the n. Okay, and so 16 million in standard form is 16, 000, 000, 000. Okay, and this is kind of where the advantage of scientific notation comes in, is that we can work with really large or really small numbers and make it understandable. So when I look at 16 million, when I write this as scientific notation, right now the decimal point's at the very end of this thing. And so what I'm going to do is I'm going to move the decimal point over 1, 2, 3, 4, 5, 6, 7 places. Okay, and when I do that, this number here becomes 1.6. So again, that goes back to the c's got to be between 1 and 10. 1.6 is definitely between 1 and 10. Times 10, and now again, just count how many decimal places you moved it. I moved it to the left, 1, 2, 3, 4, 5, 6, 7. So that's times 10 to the positive 7. Okay, positive 7. If your number is bigger, if it's a large number, then you're going to end up having a positive exponent. If it's a small number, i.e. it's less than 1, then you're going to end up with a negative exponent. So 2 hundredths in standard form is 0.02. So now for this one, it's got to be between 1 and 10. So I got to move the decimal point 2 units to the right. So I end up with 2 times 10, and I moved it to the right, so that's negative 2, right? Because my original number is smaller than the 2. 24 hundredths is 0.24, same idea, except now I only have to move it 1 decimal point over. So now it's 2.4 times 10 to the negative 1. Okay, so again, when you're over in scientific notation, when we're looking over here, okay, if your exponent is positive like the first one, that means you would take your decimal and move it to the right. If the exponent is negative, that means move it to the left. Okay, so example 1 says write each number in scientific notation. And so when I do that, the first one, the decimal point's here. I got to move it 1, 2, 3, 4, 5, 6 units to the left. So it's 7.82 times 10 to the 6th power. Okay, so for part B, I got to move it 1, 2, 3 units to the right, and I get 4.01 times 10, and I moved it to the right, so it's negative 3. Okay, and so that's, again, the way I've always done it is after I move the decimal point, here's the number I had, and I look at this number, and my question is it bigger or smaller than the 4.01? And clearly it's smaller, so that's what makes it the negative exponent. Okay, in example 2, it says write each number in standard form. So in other words, the 10 to the 9th here means move your decimal 9 places. So I have 3, 8, 9. So this would be 1, 2 places, 3, 4, 5, 6, 7, 8, 9. And then we go back and put our commas in. So comma there, comma there, comma there. So 3.89 times 10 to the 9th is the same thing as saying 3,890,000,000. Okay? Again, this is a lot more neat than that. Okay? $3.89 billion is not very easy to work with. Okay, when you write it out. Part B, it says 9.097 times 10 to the negative 5. So that means move your decimal to the left. Okay, so I have 7, 9, 0. Okay, so now from here I've gone 1 unit left. I got to go 2, 3, 4, 5. And that's where your decimal ends up. So 0.00009097 would be standard form there of that number. In example 3, it says order them from least to greatest. What I would suggest doing is writing them either all in standard form or all in scientific notation. It's up to you, depending on what you think is easier. Okay, so what I would do is I would probably write, in this case, there's already 2 in scientific notation, so I'm going to write the other one in scientific notation as well. I got to move the decimal 1, 2, 3, 4 units. So it's 4 times 10 to the negative 4. Okay. And so now you just start looking at it and you say, all right, start comparing the numbers. All right. So clearly, if you moved it 5 decimal places to the left, that's going to make your number even smaller. So from least to greatest, 2.8 times 10 to the negative 5th is going to be the smallest. Because again, you got to move your decimal point to the left so many units. And now these two, you'll notice, have the same exponent. So then when they have the same exponent, just compare the numbers. 3.2 is less than 4, so 3.2 times 10 to the negative 4th is less than 4 times 10 to the negative 4th. And that's how you'll treat that. All right, and then finally, example 4 is evaluating expressions in scientific notation. And so for these ones, you're going to want to have a calculator handy. If I want to have a no calculator quiz, then obviously I'll have to give you nicer numbers. Okay, but when I'm looking at this, what you're essentially going to do is you can multiply numbers in any order. Okay, you have 1, 2, 3, you have 4 numbers here, so you can rearrange that however you want. And so the way we're going to rearrange it is we're going to take the these numbers here, the 5.6 and the 1.4, we're going to multiply them together, and then we're going to use 10 to the negative 4th times 10 to the negative 5th and combine those. And so what ends up happening here, it says write your answers in scientific notation. So this is going to allow us to keep our answers in scientific notation. So you have 5.6 times 1.4. That's 7.84. So that's good. We're already between 1 and 10 like we have to be. Times, and now this is where we're going to use our properties of exponents. You're multiplying, so when you're multiplying, remember you take your 2 exponents and you add them together. Negative 4 and negative 5 makes negative 9. So that would be the answer to part A. All right. In part B, again, same idea. You're going to use your properties of exponents, take this guy to both things inside. And so what you end up with is you end up with 3.2 to the 3rd times 10 to the 6th. Well, 3.2 to the 3rd, according to my calculator, is 32.768 times 10 to the 6th. And now we have a problem here, though, because remember, this number has to be between 1 and 10. And so what we have to do is move the decimal point 1 unit to the left. Okay, and so now here's what I can do. I can rewrite this as 3.2768 times 10 to the 1st power. Right, move it over 1 unit to the right. But then I can't forget, I still have the 10 to the 6th on the outside here. All right, and so now what you do is you recognize, well, I have these, and I'm multiplying. I can combine those. So your final answer here is going to be 3.2768 times 10. Remember, you're going to add these because you're multiplying, so times 10 to the 7th power. Again, that example there is a little bit more in depth, as are going to be the next couple. So again, just to kind of digest that for a minute. If you have to replay the video, try that. And as always, obviously if you have issues, we will address those in class too and make sure that we're all comfortable before we get working. Okay, part C. Again, the nice thing is they've already broken this up for us. So we're going to do 3.5 divided by 1.75. Good news is that works out nicely. That's 2 times. And now again here, we're dividing. So I subtract my exponents. 10, and then I have negative 3 minus negative 5, which actually becomes positive 2. All right. And so that's your answer. Now, if the question had said write your answer in standard form, you would translate that into 200. Okay, but it doesn't say that. So I'm going to go ahead and let you guys do parts D and E on your own, see where you're at with that, and then as always, if you have any questions, just have them ready to go in class.